In this video, I'm going to solve this second order homogeneous differential equation that has constant coefficients and the roots are complex. So let's go ahead and start with the standard assumption. So let's say my solution is y is equal to e to the power rt. So that means y prime is gonna be r e to the power rt and y double prime is gonna be equal to r square e to the power rt. If we substitute these values into the given equation, we are going to get r square minus 2r plus 2 times e to the power rt is equal to 0. And this is our characteristic equation, which has to be equal to 0 because this exponential function is not 0. So it's going to be r square minus 2r plus 2 is equal to 0. We can use the quadratic formula to solve this equation. So it's going to be r is equal to negative b, meaning negative times negative 2 plus or minus square root of b square negative 2 whole square minus 4 times a is 1, the coefficient of r square, times c is the constant term 2. All of it divided by 2 times a means 2 times the coefficient of r square, which is 1. So r is going to be equal to 2 plus or minus square root of negative 2 whole square is 4 minus 4 times 1 times 2 is 8. All of it divided by 2 times 1 is 2. That is going to be equal to 2 plus or minus square root of negative 4. All of it divided by 2. That is going to be equal to 2 plus or minus square root of negative 4 is square root of negative 1, which is just I, times square root of 4 divided by 2 is going to be equal to 2 plus or minus 2i, all of it divided by 2. So my r is going to be 1 plus or minus I. So my r1 is going to be 1 plus I and my r2 is going to be 1 minus I. So my y1 is going to be equal to e to the power 1 plus I times t, and my y2 is going to be e to the power 1 minus I times t. That I could simplify further. Is going to be equal to y1 is equal to e to the power t times e to the power it, and then y2 is going to be e to the power t times e to the power negative I times t. I could simplify it a little further. So y1 is equal to e to the power t times cosine of t plus I sine of t. E to the power it is equal to cosine of t plus I sine of t. That is further simplified to e to the power t cosine of t plus I times e to the power t times sine of t. Similarly, y2 is going to give me e to the power t times e to the power negative it is going to be cosine of t minus I sine of t. That I could simplify to e to the power t times cosine of t minus I times e to the power t sine of t. Now, technically, we could say my solution y of t is going to be some linear combination c1 y1 plus c2 y2, some linear combination of y1 and y2. And we have y1 right here and y2 right here. By kind of manipulating these things, C1 and C2, if we make the assumption that C1 is equal to C2 is equal to 1/2, then we get, let's say, a solution u of t that's going to be nothing but e to the power t cosine of t. Similarly, if we make the assumption that C1 is equal to C2 is equal to 1 over 2i, you're going to get a function v of t is going to be e to the power t times sine of t. And general solution is going to be of this form: y of t is equal to C1 times e to the power t cosine of t plus C2 e to the power t sine of t. Now, these C1 and C2 are slightly different from these two. So, but to be consistent, I'm just using the same thing. Now, let's go ahead and try to find out these values, C1 and C2. And we can find it by applying the initial conditions. Y of 0 is equal to 2. So if I put y of 0, which is going to be 2, then 2 is equal to C1. Cosine of 0 is 1. E to the power 0 is 1. So C1 is equal to 2 plus C2 times sine of 0 is going to be, sine of 0 is going to be 0. So I can ignore the second term. So my C1 is equal to 2. What about my C2? To find C2, what I have to do is take the derivative of this function. If I take the derivative and simplify it a little bit, this is what I get. Y prime of t is equal to C1 e to the power t times cosine t minus sine t plus C2, let me write it over here, C2 e to the power t times cosine t plus sine t. Now, if I plug in y prime of 0 is equal to 3, so I get 3 is equal to, so this is going to be just C1 because sine of t is going to be 0. Sine of 0, 0, cosine of 0 is 1, e to the power 0 is 1. Similarly, I'm going to get from this one C2 e to the power t because cosine of 0 is 1 and sine of 0 is 0. And e to the power 0 is 1. So C1 plus C2 is equal to 3. However, I already found that C1 is equal to 2. So it's going to be 3 is equal to 2 plus C2. By subtracting 2 from both sides, I get C2 is equal to just 1. So my final solution is going to be y of t is equal to C1, which is 2, right? 2 times e to the power t cosine of t plus C2, which is just 1, times e to the power t times sine of t. And this, by the way, should be your solution to this differential equation. I hope that this discussion was helpful. Thank you very much.